Hi guys, welcome to this tutorial about differentiation year 12. The problems we are going to cover is about optimization, okay? So that is really maximum, minimum, and turning points. Now, before you start anything, this tutorial assumes that you understand the fundamentals of turning points, which are quite simply explained over here, that if you have a turning point which is a maximum or a minimum, then the gradient at those points will be zero. Okay, so we assume that you know this and you've practiced enough theoretical questions around this, and you have used the calculator to find out the actual values. Okay, because before we move into problem solving, which is the modeling questions, this assumption needs to be met. So if you haven't done that, then I would strongly suggest you go back and do some numerical questions where the data is already given to you, the numbers are given to you, you have to just apply the techniques of differentiation. Okay, because in this section what we are going to cover is really modeling questions which give you minimum amount of information and then expects you to build up on that. Okay, so it's very important that you have the grounds clear before you start this. All right guys, so here is a very classic problem. This is from the textbook, question number 8, page number 218. Okay, right, so I want you to pause over here and try to think about all the things that you can do with this question. Okay, that would be a good starting point. After that is done, draw up a shape and think about what equations you can write down, because eventually we want to convert all the numbers and diagrams expected here into equations, right? So let's give it a try. Okay guys, so what we've got over here is literally a picture version of the story at the top. So I've got a rectangle, the full width is 16 centimeters and the height is 10 centimeters, right? And we are being told that equal squares means you can see the squares over here. Of course they are not drawn to scale, but we are taking these squares off, so we have a net which really forms a cube or a box. Okay, and we need to find the volume of that box. Okay, now I want you to be a little bit creative and imagine that if we take the flaps off, yeah, these square ones, then what we have is a net which will then fold up to give us a box. Okay, the box, I'm going to show you the box in a few minutes, but I would also want you to actually try drawing one to understand what has happened, and at least try to write down the correct dimensions for the volume of that box. Okay, all right guys, so here is on the right, you can see that there is a box. It is open top. So here it's a rectangular sheet of card really, and what I've done is I've actually just done the inside measurements. Okay, because if you flap this up, if you cut the squares and fold over the flaps, you'd have a slightly smaller box, of course, right? So the dimensions of the box are written over here, and I hope that you've got the same dimensions here. If you have, then very well, we have done the visual part of this question over. And really after that, what remains is really the numerical parts, which is putting in the equation and all that, which we are going to see in a minute. Right guys, now before I change to the numerical part, which is doing the calculations, I would like you to pay attention to this. It says the largest volume of the box. Okay, so largest here means the maximum. So there you are, the word largest actually talks of optimizing a given equation to have a maximum volume in this instance, or something, maximum, say, profit or maximum length or stuff like that. Okay, it can be minimum also, because either way, at both the maximum and the minimum turning points, we have the gradient equal to 0. Okay, so please bear that in mind. Right guys, so the expression for the volume for this box is the length times width times height, which actually gives you that. What I want you to do is, guys, is basically, this is the volume of, this is the expression for the volume. You know that at the maximum volume, the the dv over dx will be 0. So I want you to actually pause over here and try expanding these brackets. Okay, it really helps to do these small exercises alongside to sharpen your skills of accuracy and timekeeping. Really important, so please give it a try. Right, guys, so this is the expression, okay, for the volume. Mind you, at the first step here, that is the sign of times, okay, so don't get that mixed up with the x. All right, so now we have the volume. For the maximum volume, we want our dv over dx to be equal to 0. So I would suggest you do that and then try to equate it to 0. And really the next step would be to actually find the value of x, which we put it back into this equation. Okay, so I want you to give it a try. Right, guys, so here is the expression for the volume. This is an x, remember, okay? So you've got 4x cubed minus 52x squared plus 160x. Now, for the maximum volume, we need to equate that to 0, okay? So dv over dx equals 0. So when I differentiate this, I get this expression, okay? Be careful with the number over here, guys, because remember, in a rush, if you make a mistake here, then the final answer, which talks about finding the maximum volume, which is actually dependent on your x value, if you get it incorrect, you're going to lose a lot of marks. So accuracy is really important, and I want you to actually start building up on accuracy as we go from here, because really, once you learn how to be accurate, then you can, with rigorous practice, try to work on the timeline. Okay, students often mix the two together and really end up losing on both of them and not scoring higher. Okay, so please be careful. Every now and then pause and try to do it on your own. It's going to really sharpen your skill. Okay. All right, so here, really what I would do is, I would just divide this expression by 4 throughout on both the sides, of course, okay, which leads to this expression here. And now this is factorizable. You can use a calculator. I'm just going to go old school style here, okay. 40 times 3 is 120. And really 2 factors of 120, such that gives me minus 26, is really a minus of 20 times minus 6. Okay, really, so I found my factors and it tells me that I'm doing things in the right order. Okay, so I'll factorize and get my 2x values. Okay, so I want you to do it whichever way you want, calculator or the manual calculation. Please go ahead and do this. All right, guys, so welcome back, and I hope you have been able to factorize this. I want you to see this, that once you have mastered the initial skill of visualizing and then drawing the shape, what really follows is quadratics. Okay, so it's a good time to talk about praise quadratics here. You can see it really does wonders. Okay, so fine, we've got the two solutions. Hopefully you've got the same answers as me. Now I would like you to pause over here and try to go back to the question, which is something like this over here. Find the largest volume of the box. Okay, I want you to try to find this volume based on the answers we have got over here. There's something in there which you are going to discover. Okay, and I want you to do it first, and then I'm going to talk about it. Okay, so please pause and try to find your maximum volume answer, and let's see whether our answers match or not. Right, guys, so what do you think your maximum volume is? Well, I've got something interesting for you. Okay, so look, when I take these two numbers, I'm inclined to think that I'm going to consider x as the higher number, which is the 20 over 3. Okay, but when you put that in the expression, you realize that we actually get a negative volume. And I want you to think why that is happening. Try to explain it to your friend graphically why that is happening. Okay, it's a really good point, and actually a point which I could, as an examiner, take to to double check you out on your understanding. So it's a good time to actually pause here and try to understand why taking the higher value of x still gives you the volume which is not our correct answer. Okay, if you can answer that question, I would say you're really smart. Okay, so please try it. If not, just stay with me and I'm going to reveal the answer. Okay. Right, so hopefully you have got the answer like me. I have decided to go with x equals 2, although it is the smaller number compared to 20 over 3, which is a bigger number. So the maximum volume which I get is 144 centimeter cube. I've tried to do this without a calculator to just demonstrate the fact that, you can really use your biocalculator, which is your brain, and it actually gives you, a more convincing and strong answer. Okay, if you rely on a machine which is a calculator, sometimes you don't know. I've often found students don't know whether they're right or wrong because they are reliant, whereas if you are on your brain, the brain does have subtle questioning powers, and it does really, it's trained to double check before it actually comes to a conclusion. Okay, so I would rely on that. So this is my answer. Now, did you get a chance to actually think, or come up with an explanation why the higher value of x actually gives you a smaller answer? It's an interesting thing. Okay, so pause and try to discuss this, or try to jot something down. It's a really important point. As I mentioned, I'm going to reveal the answer in a few minutes. All right, guys, so if you are wondering why the volume is maximum at 2, then imagine, try to, I've actually gone back to try to draw this graph, but I've just done a sketch over here. It's not drawn to scale. So here we have the graph of a volume with respect to, the length x. Okay, so it happens to be a curve similar to this, where you can see that the turning points happen at these 2 points, but the way the graph is designed, you have the maximum as the value which is on the left here. Okay, so if you try to actually plot this graph using a graphical calculator like GeoGebra, I've tried to actually do it, but I couldn't translate it here because the axes were quite wide and it just really didn't fit in. Okay, but if you try, you'd see that the graph of the volume expression actually has this shape. Okay, so at the higher point you actually get the minimum value. All right, I hope that explains, and I hope you have used this tutorial with the various prompts given to you to actually bring the best out of modeling. Enjoy. Thank you very much.